All right, here we are. We're back in action, ready to rock. Today we're going to be learning about students' t-test, but for independent samples. So this is a t-test for independent groups. If you guys know, we learned last about the t-test for a single sample and the t-test for correlated or paired samples. So we learned about those, and now what we're going to do is independent groups. This is where you can take two groups of people and test them to see if they're different on the same dependent measure. And this is probably the one that's the most useful for anybody. There's the garbage truck. Hello, garbage truck. All right, back at it. So students' t-test for independent samples is where we're going to take two groups and we're going to compare them to the idea that they come from the same place. We're going to calculate the probability of that, and then we'll take our steps of hypothesis testing and answer the question, are these two groups different, or is one higher than the other, depending on what you want to do. The two groups that we're going to be using, they could be any two groups, any two mutually exclusive groups, that is. So the groups can't be like, you know, I am a Kings fan and a Warriors fan, right? So you can't have that. I could use that as an example. Maybe I'll use that as an example, but you'll have to assume that everyone who's a Warriors fan, me, is then not a Kings fan, right? Now I'm a Sacramento guy, and so now I support the local team, but I grew up in the Bay Area and that was my team. So if we say independent group, you have to assume that the groups are mutually exclusive, that they don't include people from both settings. So you might have a marker for your groups, you know, people with IQs above 100 or people with IQs below 100, because nobody is in one group and in the other. So those are mutually exclusive groups. Male and female, excluding the transgender stuff. Don't get me started. Come take my human sexuality class if you want to talk about the legitimacy of gender as a construct. But if you're a male, you're not a female. If you're a female, you're not a male. So those are mutually exclusive groups. And it's not like you switch. That way we could study them and say, are they different on said thing? Whether it be jumping ability, financial literacy, grades in school, we can ask the question, are there differences between these groups? And we can find out what are the markers or the variables that would distinguish people that then predict outcomes, and how can we help people in that vein. For all of you social justice warriors out there who really want to improve the inequities in our lives, this is the t-test that you want, because you want to be able to divide people into two groups and then say if they're different, that's representative of misogyny or racism or whatever you want to talk about. This is your test. If you love social justice, you need to learn this student's t-test for independent groups. That's another topic we'll talk about, not in a recorded sense, sometime in class. All right, guys, let's learn students' t-test for independent groups. Okay, for students' t-test, we're going to talk about two different groups of people. And these people are not inherently mutually exclusive, but we're going to deal with dog and cat owners. So we're going to treat them as though they are exclusive people. My contention is that dog and cat owners have different amounts of depression. So if you have a dog or you have a cat, I think you have a different amount of depression. This is going to allow us to do a two-tailed test, because I said different. I didn't say dogs make you more depressed or cats make you more depressed or dogs make you happier or cats make you happier. What I suggested is that there's a difference. And so that's our hypothesis. We're just investigating the difference between dog and cat people. Dogs we'll have over here, and cats we'll have over here. Now in the previous iteration, when I did correlated or what we call paired sample t-tests, you had to have two measures for each person, right? They had to be measured before, and then that same person had to be measured after. That's because their score from the beginning, if you remember the free throw shooting example, the people that were good at shooting free throws had to be compared to themselves after Professor Frizzie's free throw shooting academy. So in this sense, these two groups of people are independent. They're not the same. Whereas before, in the paired sample t-test, it was the same person measured twice. But clearly, as you can see here, there are dog people and there are cat people. Now I have a dog and a cat. Technically, we kind of have two cats. There's a feral one that you've seen here. on several videos. But I like dogs better, so I'm going to be in the dog group, right? So you can have a dog or a cat, but you're a cat person or a dog person. That's really the issue. You have a favorite, and dogs are my favorites. So, question: does being a dog person or a cat person make you more or less depressed? Is there a difference between them? See, I found that there were 6 dog lovers, and I actually only found 4 cat lovers. Now you might ask yourself, well, there's a different number. That's the cool thing about an independent sample t-test, is that it doesn't matter if there's a different number. By the way, this is a made-up example. I'm making up all these numbers, and you'd never do a t-test for independent means with only 4 in one group and 6 in another. That's not sufficient of a sample to suggest that you're estimating the population's parameters, okay? That we need like 30 in each group, okay, at least. In this instance, I'm just going to do this so I can show you the math easily. It's a total violation, but recognize I'm doing that violation so that we can fit all the math here on this whiteboard. I'm limited in my scope. I don't have the ability to do some giant thing and have 30 people and then take a week for us to do one hand calculation of an independent t-test. Let's figure out how depressed dog people are and cat people are. So I use the Beck 2 Depression Inventory, BDI, the Beck Depression Inventory, and I found the following numbers. $20, $10, $15, $12, $15, $20, $30, $20, $15, $25. Now, I'm without my, I don't know where my phone is, so I gotta figure out a calculator for this. I'm gonna actually use Excel. So if you wanna follow along with Excel, I can show you how to do that. So I'll just make one category that's dogs, and then the next one over will be cats. Now I'm gonna leave some space here because we do some calculations in between here and here. So I'm gonna leave some space for them. And we'll see if I can show you the computer screen here. All right. You guys can look over my shoulder as I do this. I think you can see that a little bit. All right, I'm gonna try and do this here. If you guys can see that or not, I'm not sure. I'm gonna move this a little bit closer. So you see we got the dogs and the cats. So for the dogs, you know what I can do? I can make this bigger. Bam. Haha. Now, okay. You guys see the dogs and the cats. So dogs, we had 20, 10, 15, 12, 15, and 20. And for the cats, we had 30, 20, 15, and 25. So these are our numbers now. In order to get averages, it's very easy on Excel. I'll teach you all of this when we do our SPSS assignments live, but I'm just gonna do this really quickly so you can see what happens. If I wanted to find the average for that group, I would just get the average. And same thing here, I'll just highlight it and I'll hit average and it gives me the average. Now, this one I'm going to create as our deviation score, and this one will be our deviation score squared. Similarly, deviation score and deviation score squared. Okay, how do I do it? I simply put equals this number minus, And then I'm going to put in there my mean, which is 15.3. I can click and drag down. And I can then make this one equal to this number times this number. And click and drag down. And I'll get my sum of squares. So now I have all the squared deviations. I hit auto sum, and it gives me the sum of squares for group 1. So I'm going to put sum of squares 1 equals 83.33. And I'll do the same thing over here, which is to say that I want to create deviation scores. And deviation scores squared. When I've completed that, now I have the sum of squares for group 2. Okay, notice something. I've got, oh, you guys can't see that at all. Okay, there we go. I've got two different sum of squares here. I've got a sum of squares that says it's 125, and a sum of squares that says that it's 83. So what are we going to do to reconcile that? Well, the way that an independent sample t-test reconciles this is that it takes into account the fact that there's a different number of dog people than cat people. Now, it's not saying that dog people are better than cat people. Don't freak out on me, everyone. But what this is saying is that because we have a larger number here than we have here, we're going to take a little bit more credit from this one than this one in estimating the population variance. But you have to remember something. What you have to remember is we're not saying this one's better than this one. In fact, when we're saying this one gets more credit at estimating the population variance than this one because it's larger, we're actually saying that they're the same. So the premise here is that, look, if you had 6 as a sample and 4 as a sample, which one would you choose to estimate the population variance better? Obviously, you'd choose the 6. But the trick in the independent sample t-test is if the null hypothesis is true, these aren't from different places. These are from the same population. So what we can do is say instead of 6 or instead of 4, we can take 10. And 10 is far better than 6 and far better than 4. So if the null hypothesis is true and there's no difference in the depressive levels of dog lovers or cat lovers, then our null hypothesis population that we're trying to estimate with these two variances would be the same. If, however, that's not true, then we'll figure that out here with the independent sample t-test. Or we'll figure out the probability that that's not true. All right, so we figured out our sum of squares for each group. The sum of well, we figured out the mean for each group, right? This is 15.3 with a line over it. And this one was, there we go. You guys are getting, I gotta shut the garage door. You guys are getting all washed out here. I literally just pushed the garage door button. You know the little button that you push to open the garage door? And the whole thing broke. I hope it's not going to be that kind of a day. But, okay, we have got an average, right? This is the mean for group 1 is equal to 15.3. We've got the mean for group 2, which is equal to 22.5. The question is the difference between those means sufficient for us to reject the null hypothesis and say that these are from different depression groups and that the factor of being a dog person or being a cat person is what distinguishes you into a more or a less depressed group? We've now calculated sum of squares for group 1. Sum of squares for group 1 is equal to 83.33. It's just, you know, the same extending thing for forever. And then sum of squares for group 2 we figured was 125. These are telling different stories about the variability of the group. Now we need to take into account how large these groups are. So when we have sum of squares for group 1 and sum of squares for group 2, we now need to take into account how large each group is in making these particular comparisons. So we'll do that in a second. I'll see you on the... And we're back. Okay, So I'm going to take those numbers that we just got for dogs, which was 83. That's the sum of squares for group 1. And cats, that was 125. Okay, so these are the sum of squares for group 1 and for group 2. Sum of squares for group 2. What we do with the sum of squares is we're going to divide it by the degrees of freedom for each group. If you remember, dogs had 6 people in it, so the degrees of freedom is 4. I'm just kidding, it's 5, right? Because n minus 1. So when we divide the sum of squares by n minus 1, that gives us S2 for group 1. S2 for group 1. So divide that by 5, and that will give us S2 for group 1. Similarly, if we divide this by n minus 1, actually I'll just write degrees of freedom so you can see it's the same thing. N minus 1 is the same thing as degrees of freedom. So, how many degrees of freedom do we have in the cats group? There are only 4 people there, so that makes 3. 3 people is our degrees of freedom, so we divide 125 by 3, and that gives us, I forget what it gives us. Anyway, do this one. S2 for group 2 is 41.67 basically. S2 for group 1 is equal to 16.6 for forever. S2 for group, this is S2 for group 2 is equal to 41.6 for forever. So now that we have an estimate right here of the population variability from group 2, and we have S2 for group 1, so we have the estimate here, you say, well, which one do we use, 16 or 41? Turns out that 16 and 41 are quite disparate. So how are we going to reconcile that? 16 comes from a group with 6. 41 comes from a group with 4. So we're going to take the proportionality of their n size and we're going to create something called S2 pooled. Okay, so what S2 pooled is, it's going to take into account how large 16.6 is given that this came from a group with 6 and 41 and how large that came from a group with 4, and it's going to pool them together. Remember we said 10 is better than 4 or 6, so we're going to pool it now. We're going to pool this estimate of the population variability. So I'm going to write the formula here, but I don't want you to freak out because you know all of these terms. Okay, so S2 pooled is equal to degrees of freedom for group 1, which is over here, divided by degrees of freedom total. So group 1 had 5 degrees of freedom. Group 2 had 3 degrees of freedom. So what does that mean? 5, 3, it's going to be 8. And then S2 for group 1 plus the degrees of freedom for group 2 divided by the degrees of freedom total. This is our S2 pooled formula. So now we're going to need to take this and that and input the degrees of freedom for group 2, which was 3, the degrees of freedom total, which is 8, the degrees of freedom for group 1, which is 5, degrees of freedom total, which is 8. Once we do that, we'll get S2 pooled and we can move on to finding out whether or not dog people and cat people depression level is different. Alright, here we are with S2 pooled. So for us, S2 pooled, it's going to be equal to the degrees of freedom for group 1, which was 5, yes, 5, divided by the degrees of freedom total, times S2 for group 1, which we all know is 16.6, okay? plus the degrees of freedom for group 2, 3, divided by the degrees of freedom total, times 41.6. And when we do all that, what we find is S2 pooled is equal to 98.95. Now what? We have that, but we have to take into account how large each of our groups are. So to create the unbiased estimate for the population variance for group 1, we're going to take S2 pool and we're going to divide it by n for group 1. In our case, 98.95 divided by, we had 6. So when we do that, it tells us that the S2 for group 1 is 16.49. Now we need to do that for group 2. Again, we'll use the same exact S2 pooled. And look, all that changes here is that S2 pooled is the same, but the n for group 2 is different. So when we divide 98.95 by 4, because that's the n for group 2, we get 24.739. So now we have S2 for group S2 sub M2, and we have S2 sub M1. So now that we have those, we can get S2 diff, which is the unbiased estimate for the distribution of differences between means. Crazy, right? How do you do it? It's S2 sub M1 plus S2 sub M2, or 16.49 plus 24.73, which equals 41.23. This is our variance estimate for the distribution of differences between means. But we actually need S diff, which is the average amount an individual group will differ from the mean of its group when we have these two groups. So now to create S diff from S2 diff, we take its square root. So the square root of 41 equals that. And that is 6.42. Now we have everything we need to calculate a t-value that we can then compare to our t-critical. See you in a second. We're back. The t-obtained statistic or the t-value that we're going to create for an independent group t-test is the mean for group 1 minus the mean for group 2 minus mu for the distribution of differences between means, divided by the standard deviation for the distribution of differences between means, or S diff. This is just like S sub m, and this is just like the mu in the paired sample t-test. This will always be 0. The reason being, if there's no difference, the average difference for that population will be 0. We've calculated this, we know these, so we can do the whole thing together. Mean for group 1 was 15.3. Mean for group 2 was 22.5 minus 0. That's always going to be 0. So 0. Divided by what we just figured out S diff was, which is 6.42. That yields for us the t-obtained statistic of negative 1.1 0.1608. So our T obtained is that. Now what do we do with it? We're almost done here. We've got our T obtained statistic. Now we need to find our T critical value. Our T critical value in the book is going to be found by taking the degrees of freedom total, which for us was 8. And we know that this is a two-tailed test because we don't know if it's dogs or cats are going to make people happier. And so we'll see that a two-tailed test at 0.08, we'll use a 0.05 alpha level, is 2.306. So our T critical value is 2.306, and for our, it's positive or negative because it's a two-tailed test. The T value, or our T obtained that we got, was a negative 1.11608. So if you just think about that, here's a T distribution. We would need to get to a negative 2.3, right, to be able to reject the null. And because it's a two-tail, we could also get to a 2.3 positive, and then we would have been able to reject the null up here too. The two-tailed test means we didn't know what direction the independent variable would influence the dependent variable. But in our case, we obtained a negative 1.11. Okay? So clearly we're not going to reject the null hypothesis. How do we go about doing the 6 steps of hypothesis testing now? We're going to go through them all together since we have the T critical, the T obtained. Let's figure it out. Step 1 of hypothesis testing is to restate the question as a research hypothesis and a null hypothesis about the populations. So, step 1. Population 1. Let's say dog people. Population 2. Let's say cat people. So there's the two populations. Our HO is population 1, and population 2 will not differ, that they will be equal on their depressive level. Our research hypothesis is that population 1 will be different or not equal to population 2. That's step 1. Step 2, we've got to determine the characteristics of our comparison distribution. That is the mu for the distribution of differences between means, or mu diff. That's going to be 0 because if there's no difference in depressive level between dogs and cat people, the average amount of difference is going to be 0. But we also know that there's going to be differences, variability, and so we have to determine that. We know 0. We found out that S diff was 6.42. That means that the depressive level is going to differ on average for an individual, group of the size that we had, which was 10 people, by 6.42. Even though they're going to differ around a population mean of 0. Step 3. We said this is a two-tailed test. Why? Because we didn't know if cat people or dog people would be more or less depressed. So we put a two-tailed test. We used a 0.05 alpha level. And we determined the T critical was a negative 2.3 or 2.3 positive. We have those. Now, step 4. Step 4 was to determine our sample score. Now, we know that the mu difference was 15 minus 22.5. So we found the mean difference. Mean difference. Okay, Google. What's 15.33 minus 22.5?
The answer is minus 7.17.
Minus 7.17. So that's our mean. Now we have to put that, remember, because step 4 is to determine your sample score on the comparison distribution. So on the comparison distribution means here. We found that our T obtained was negative 1.11. And our T crit, where we were going to reject the null, was a negative 2.3 or a positive 2.3. Our score was a negative 1.1. What that means is for step 5, we're going to fail to reject the HO. What does fail to reject the HO mean? Well, let's go back to our HO. Our HO here says population 1 is equal to population 2. That means that cat people and dog people do not differ in their depression level. So, dog and cat people are the same with regard to depression. That's it. There you go, folks. Independent sample t-tests.